Hello các bạn trên fanpage cũng như là các bạn ở lớp IELTS. Hôm nay thầy sẽ ghi video để cùng với các bạn đọc một bài báo mang ở chủ đề science, chủ đề khoa học. Bài báo có tựa đề là Why did humans evolve to blink? Có nghĩa là cái việc tiến hóa của con người, tại sao con người tiến hóa để có để chớp mắt. Thì bây giờ thì đây là cái bài báo nó phát hành vào hôm 24 tháng 4 và bài đọc có độ dài 6 phút. Như thường lệ thì bây giờ thầy sẽ vào cái app THUēt để mình cùng đọc từng khổ một. Nó có cái phần dịch cho các bạn cùng theo dõi ha các bạn. Tại sao con người tiến hóa để chớp mắt? Vậy các bạn sẽ nghe.
Why did humans evolve to blink?
Blink có nghĩa là chớp mắt.
To approach a question 400 million years in the making, researchers turned to mudskippers, blinking fish that live partially out of water.
Very good. In the making là quá trình, những năm tháng hình thành.
A magnified view of the human eye shows the pupil, the surrounding iris, and capillaries on the surface of the eyeball. It's long been known that people blink to keep their eyes moist and protected, but less known is how we evolved the phenomenon. A new study on an amphibious fish called a mudskipper offers clues.
Ok, bây giờ mình sẽ tiếp nha.
By the time you finish reading this sentence, you will have blinked at least once. Humans blink 15 to 20 times each minute, a mostly unconscious snapping shut of the upper eyelid that keeps our eyes clean, moist, and protected. It's a reflex shared by nearly all limbed land vertebrates, what scientists call tetrapods, and is almost completely absent in aquatic animals like fish, their ancestors. A team of evolutionary biologists wanted to know, how and why did blinking evolve? Since fish began to crawl onto land nearly 400 million years ago, studying the process in action is impossible. Not only that, eyes, muscles, and other squishy bits don't generally survive in the fossil record.
Okay.
So, the researchers turned to mudskippers, a group of amphibious fish living in mudflats in Africa and Asia that evolved blinking independently of tetrapods. Using ultra-high-speed video and state-of-the-art scanning technology, a new study published in the Proceedings of the National Academy of Sciences found that both non-blinking fish and mudskippers have always had the muscles needed to blink. That means that our tetrapod ancestors transitioned to dry land, and the requirement to see well, is likely what spurred the phenomenon of blinking. The fact modern-day fish have the muscles to blink has brought us a new perspective on some of the requirements to actually see on land, says Sandy Kawano, an evolutionary biologist at George Washington University in Washington, D.C., who wasn't involved in the study. That actually suggests that there's really not that big of a hurdle in order for fishes to be able to see effectively on land. Fish out of water. For its first few billion years, life on Earth was a watery affair. Around 375 million years ago, however, a few fish made their first tentative moves out of the ocean and onto dry land. This brave new world filled with potential food and a lack of predators promised almost limitless opportunities, but only if the tetrapods could see them. If their eyes were built for living underwater, once they got onto land, things would have been really blurry. They would have basically been nearsighted, Kawano says. They would also have suffered from chronic dry eye, since the cornea needs to be wet to protect and oxygenate the eye. Animals also needed a way to remove debris and otherwise protect their delicate eyes. That's why nearly all tetrapods accomplish this by blinking. Blink of an eye. To understand how blinking first evolved, authors Tom Stewart of Penn State University, Brett Aiello of Seton Hill University, and Neil Shubin of the University of Chicago teamed up with engineer Simon Sponberg at Georgia Tech to study two mudskipper species, Periophthalmus barbarus and P. septemradiatus. High-speed video recordings of the blinking mudskippers in the lab revealed that the walking fish accomplish this feat by pulling their eyeball back into its socket to allow the skin to close around it. Computed tomography images of the mudskipper's musculature, particularly around the skull, identified the 6 muscles needed to retract the eye, muscles that they shared with another study species, the closely related but fully aquatic round goby, Neogobius melanostomus. A custom-built humidity chamber showed that both mudskippers blinked more frequently in drier air. When the researchers applied small particles to the mudskipper eyes, 97% of them were removed from the cornea with a single blink. And when the scientists used a small probe to touch the eye, they found the mudskippers reflexively blinked, just like tetrapods. This means that blinking serves the same function in mudskippers as it does in people. This shows you can have fully terrestrial-style behaviors with just a retraction and a simple fold of skin around the eye. You don't need to have something as structurally elaborate or complicated as our own eyes, ILO says. Powerful methods. Bruno Simos, a zoologist at the University of Plymouth in the UK, calls the work very, very cool, praising its elegant methods to identify why and how blinking came to be. They used quite powerful methods to test, step by step, why these animals developed a blinking system, Simos says.